that works well.
Okay,
It
Yeah.
doesn't
okay,
work
now you
real
might
well.
have to, okay, you have to.
I
allow
did
it.
it once. I recorded it to my computer and it was a pain
No,
in the
that's,
butt.
well, no, I've done that before, and
Oh,
it's just
well,
an MP4 file. and
Yeah, it took forever.
But it's big. Well, I think
Yeah.
what'll happen is it'll be on your, go to your, my U Albany and Albany.
Oh, it'll be there?
It'll be in your Zoom, your Albany Zoom account
Okay,
is where, and then look under recordings.
Right.
And that's where it'll be.
I just want to keep you, okay, step over that without
Tripping, kill
tripping if you
myself.
can. I wanted to get my ice water.
Yeah, and you're kind of sandwiched in between.
No, no, well, that, yeah, I'll see what I can.
All right.
Okay, I need some water here.
Absolutely.
Hi.
Recommendation? I do, yeah.
Landed the ball.
I never got it. Oh, in the movie? Yeah.
Yeah.
So, they do that so many. It's so standard. Yes. I somewhere. It takes 4 or 5 years both to find out till chapter 7. But I did read it. Yeah, they were there in the movie. Not true that way. Right. Yeah. No, yeah. Oh, yeah, yeah. He's gonna. And he ways it a little more tongue in cheek. Right. It goes up how he is, what it has short. Yeah, yeah, he's got. The blue shirt. No passing notes in class. Have you seen? I haven't seen any of those.
So I'm sure that I should have brought mine. Nice, so that would have been. The reason I brought it is. There's no condensation. It's drier here than it is in the middle of the. That's an important physics. Like, hi, good to see you. Thanks for coming.
Oh, duck is in the cast? Yeah. I had to put that in. I had a solar guy over. Yeah. Got to replace the inverter. Translated it. I got real confident. It only lasted about 15 years.
You had it for 15 years?
14.
Okay, that's great.
I guess I'm gonna add a battery.
Really?
Yeah, I like.
Oh. How big one? You have a power wall?
No, just 5 kilowatts. So-
8 kilowatt-hours, 5 kilowatt-hours.
Well, once you get a new inverter, the battery operate on smooth. My old one, except that.
Interesting.
Anyway, I told him he should come to your office. He wants to know the serious.
Yeah.
No, did you see that science paper from Australia?
Which one?
About the intensity of rainfall?
Maybe.
Measured it down to some hour or something.
Oh, yeah, really high resolution. Oh, I would.
It's been like 10%.
Well, that's really hard to measure. No, I'm going to address that today. I have a thing on intensity and all. So there's a slide here. But anyway.
Okay, we probably should get started. Want to welcome everybody to what is the last presentation of the fall semester, correct, James? I think most of you know I'm Ed Fitzgerald, the president of the Emeritus Center, and we have with us our speaker, Dr. Chris Walcek. I want to thank Chris for his flexibility. He was originally scheduled, I think, for the spring semester, but then we had a last-minute cancellation due to surgery, the speaker's surgery. So not my surgery, but in any case, that was actually Philip Morris, right, the CEO of Proctor's. Yeah, I think he was having, what was surgery for? Was it
Leg surgery.
some leg surgery?
He had a tibia fracture, stress fracture.
Yeah.
So he's in a lot of pain.
Yeah.
But actually, his surgery is tomorrow. And he's on bed rest until then.
Yeah. So he's going to be, we did the flip flop. He's going to take Chris's place at the as the first speaker of the spring semester, which is at the end of January.
30th.
Yeah. Okay, so I'll turn it over to Dean, our program chair, who's going to do the formal introductions of Chris.
I'll use the mic, although I was taught to enunciate from the diaphragm. So Dr. Chris Walcek retired in September 2020 after a 34-year career at the UAlbany Atmospheric Science Research Center. There he studied cloud physics and air pollution meteorology. His research is funded by the National Science Foundation, NASA, the U.S. Department of Energy, U.S. Environmental Protection Agency, the Air Force, and the New York State Energy Research and Development Authority. He received his PhD from UCLA and worked at the National Center for Atmospheric Research in Colorado before coming into Albany in 1986. Chris, it's all yours.
Thanks, everybody. Thanks for coming. It's a pleasure to talk here. I moved here from sunny Southern California, but I'm a weather person, so I love weather. Oh, you bet I do. Oh, this is the best place in the world to live for me. And one thing I do like is I'm a big fan of local, eat local, shop local, go to local art. And this is a talk where I'm going to give you a talk about local climate measurements right here in your backyard. Okay, so I'm going to present some local measurements, temperature, rain, and then I'm even going to look at some paleo records, what climate looked like before we had thermometers. And then I'll make a statement about how things might change here locally in upstate New York, Albany. Again, usually when you hear talks of global warming, everybody gives you this global perspective. And this is a graph. And by the way, another thing, I want to apologize in advance. I am a number geek nerd. Since I was a little kid, I had a weather station in 7th grade that I recorded temperatures every day, and I was doing spreadsheets before there were spreadsheets, and I just loved numbers, and I was able to have just a wonderful career crunching numbers and programming computers, and I had a lot of fun with numbers. A common comment I've heard people say is, Chris, you showed us a lot of graphs. Right, you're going to see a lot of graphs, and I hope they make things clear to you, but it's a little bit of my zeal of I like numbers. But anyway, this is a graph showing the average temperature of the whole world, compiled by a research group out in England, the Hadley Climate Research Center, and each dot on here is an annual average since the 1850s. That's funny that this screen is cropped there. That's a little bit, my screen shows it there. And what you see here in each year, and this is an average of thousands of measurement and thousands of stations, and then they compile it and average it over the whole surface of the earth here. And what you see is and then in blue here is is climate. It's a 30-year average of those numbers, and that's a important take-home lesson. Anything you think about in terms of climate change has to discuss it at a minimum of a 30-year time averaging period. Any storm yesterday or a snowstorm tomorrow, that's not climate. You have to look at the 30-year average, whatever you're studying to talk about climate. But anyway, so this 30-year average is fluctuating around And it's taking off since about 1970. We're going off the chart. So this looks like a runaway problem of climate just catastrophically changing. However, what does this look like here in Albany? By the way, just some numbers here. We've had about 2 degrees Fahrenheit. If I look at that climate, the 30-year average, and the scale of this graph is in degrees centigrade. So it's a few tenths below some average to a few tenths of 1 degree above. So that's the scale of this graph. This blue curve has warmed 2 degrees Fahrenheit since the 1900s. And we've had about 1 degree Fahrenheit of warming since 1970. Oh, and this is everybody pretty much in the scientific community agrees that humans started really measurably changing the climate at around 1970. So we've had about 1 degree Fahrenheit globally of warming. Now, right as the last slide I put on my graph, I went to weatherunderground.com and 9 a.m. this morning, this is a picture of temperatures measured in Albany. Okay, and by the way, the temperatures I'm going to be showing to you are measured at the airport. If you see here a scattering, look at here, off in Troy there, 36 degrees. Over here in Guilderland, 25 degrees, 10 degree Fahrenheit fluctuations locally. So when someone tells you, hey, what's the temperature right now? Depending on where you're sitting, it could be as much as a 10 degree Fahrenheit range. Okay, so let's just keep that in mind. Locally, things are changing by 10 degrees. Now, this is a graph showing the temperature. Every day, they've been dutifully recording temperatures at maximum, usually in the late afternoon, right around now. And then a minimum is usually right around sunrise. And this is the sunrise temperature on December 5th every year. I customize this just for you guys. And so what you're seeing here is the temperature from 0 to 70 measured since about 80 years ago. And I have this on a spreadsheet. I'm crunching it all the time. And what you see here today, this morning, when you woke up, it's 27 degrees out. Okay. And look at what it looks like over the entire last 80 years. Okay, what is interesting, I like New York Times actually has a good, they show the statistics, but I like spreading it out over time because you get a sense what's happening on December 5th here. You can see some cold December 5ths are down in the 5 and 10 degree Fahrenheit range, and some hot December 5ths are in the 45 and 50 degree range. That's a 40 degree temperature range on this day. 40 degrees range. And it looks, I don't know if you see a pattern there that looks ominous here, but this is what the minimum temperature looks like. What about the maximum? That's actually a fork on my weather app. What's it supposed to get up to today? My car told me it was 41 as I was coming in today. It's supposed to get to about 44, but anyway, here's the maximum temperature. Again, over the last 80 years, today it looks like it's kind of an average of what it's been. We have had highs in the 25 or 30 degree range, all the way up to the 60 or 65 degree range. Now, again, that's a 30 degree Fahrenheit range of temperatures on this day. So what is the climate for this day? Definition of climate, take home lesson if I give you a quiz. You have to average things for 30 years, according to everybody in this field, minimum of 30 years. Okay, so here what I'm showing is that same data, but I've done the 30-year average. So this is how climate has changed here in Albany. Right now, this is the hottest minimums we've ever had in the record. This is 20, maybe 27 degrees. Right now, we're right at the average here for the last 30 years before that. But that's the hottest that 30-year average has ever been. Back in the 60s, it was down in the 25. We're at 27, 2 degrees warming. Remember the global average, 2 degrees? It's right up there with the 2 degree average. The high temperature has risen. It's about, right now, again, we're in record territory. We did have high temperatures close to these numbers back in the 60s, and we've risen and coming up to that. But notice here, we've had about maybe 5 degrees Fahrenheit warming since 1970, 5 degrees warming, which is more than double the global average. temperatures. And we've had even more, 7 degrees warming here since 1970s in the minimum temperatures. And the reason I have this glass here is there's a reason why minimum temperatures are rising faster than maximum temperatures. There's a little bit of interesting physics there. But anyway, we are seeing global warming. Now, that alarming looking graph that I showed you at first, temperatures going off the chart, if you plot it on the same scale as these temperatures, here's that Hadley Climate Research Unit trend over this identical period. 2 degrees warming over the whole record there. And what you kind of see here is the context of that very alarming looking global warming in terms of here in Albany, we're seeing warming way more dramatic than the rest of the world. You can tell your grandkids, we are at the bullseye of where global warming is happening. We've seen more warming than the rest of the world here. Now here's, by the way, I want to get a feel. This now is this is the annual average temperature up to last month, November. Okay. Now, has this been a hot year, an average year, or a cold? I'd like to show of hands. Don't cheat. Okay. Now, if you look at temperatures, this is like it's close to an annual average. It's 1 month shy of an annual average. But has this been a hot year? Average year or a cold year? What do you think? Now, here's the deal. Let's look at it. If you kind of look at here's the annual numbers. Again, the coldest years are 47, 48. The hottest years are 51, 52. That's like a 5 degree Fahrenheit range. That's the norm, 5 degree range in the annual. It wouldn't be unusual that you get next year's 5 degrees warmer than this year. But let's take the middle of this, or the hot or the cold. How many people think it was this current year so far has been hotter than average, the hotter third? 1, 2, 3, 4, 5, 6. Okay, what about average? Anybody think it's been cooler? 1. Okay, by the way, just if you gave that question to monkeys, a third of them would get it right. But no, you're right. It turns out this so far, November is in the hotter years. We're at about the 10th percentile or so. It's one of the hottest years. But it's not unusual. We've had hotter years than this year, okay, so far. So this is what's happening in Albany. Now, again, let's put this in the context of that global number. If you look at that pattern there, and by the way, these are raw measurements. This is what was recorded in farmers' almanacs over the whole, this goes back to the 1790s. They've been measuring high and low temperatures. So every dot on this graph here, there's a high measured each day, a low measured each day. And so you have 365 times 2, you have 730 measurements. Every one of these is an average of 730 temperature measurements measured during the year. That's what each dot on this graph is. And you can, I think I see a pattern there of climate change, but let's do the 30-year average. Here's the 30-year average of Albany temperatures. And so far this year, and what you're seeing is we're right now at the record 30-year average we've ever seen. This last year pushed us probably, I bet we're within 1/10 of a degree of something we measured back in the 20s. And we're within a degree or so of something measured back in the 1800s. But what's most important here is that since 1970, look at it, that's almost a 2 degree Fahrenheit temperature rise, which is the Hadley Research Unit here was only 1 degree Fahrenheit of warming since 1970. So we're double the rate of warming here in Albany. Okay, let's see. Yeah, that's the point I made there. What it amounts to is local climate change can be very different from what's happening globally. Now, this is a map that I pulled out of an EPA report of the actual temperature trends or the change in that 30-year average temperature measured over the last 100 years since 1900. Okay, and what you see here is, and again, notice the temperature change here. It's going from there's some places in the US here that are cooling down. And there's some places that are heating up and by the way, they're cooling down at 1 degree Fahrenheit over the record. There's other places that are warming at about 3 or 4 degrees Fahrenheit. And the global average is in this 2 degree Fahrenheit range. So you can see here, there's places that are cooling way cooler than the rest of the world. There's places that are warming up way faster. And if you zoom into New York, what you find here, even in New York State, we here in Albany are in the hotter, we're heating up faster than average here. in Albany. If you go off to Binghamton and Cornell, they're not, they're down in the nothing. They're, I don't know whether they're better off with us. I don't know, but that's what's happening. There's a lot of fluctuations with climate change locally. Okay, let's start looking at climate extremes. Everybody's, that's the new buzzword. And here I'm showing you here now a graph of the number of days each year that are above 90. Those hot, sweltering summer afternoons. And so you can see here, and each dot here, notice back here in the 40s, 20, 30 days a year, the whole month a year above 90 degrees. And last year we only had 3 days above 90. And if you notice the 30-year average, it's on a downward trend. We're getting fewer hot days in Albany, although it has picked up about, maybe in 1980s, 1990 here, we had maybe 7, 8 days. We're up to 10 now. So maybe there's been an increase just in the last 10, 15 years in that 30-year average. But the number of hot days is dropping. Okay, so this picture of the world sweltering in heat is not applying here in Albany, at least. What about the other end of the temperature spectrum? Go to those cold January mornings. I was hoping to give this talk in January, and maybe a 10-degree Fahrenheit morning. Now, this is the number of really cold nights below 0. Okay, so these are, again, now notice here, that number has gone from nothing all the way up to 20 or 30 days a year. The cold winters will get a whole month's worth of below 0 temperatures. And notice what's happening to the 30-year average. It's dropped by a lot. We did have, I don't think we've had it. I don't think we're going to get any below 0 days for the rest of this month. We usually get the below 0 days in January and February. So, but there's a chance this number will come up a little bit here. But notice it's gone from 2 weeks a year down to 1 week a year. We're getting a lot less cold here in Albany. And this change, 7 whole days extra less cold is much more robust than the change in the number of hot days. So this is the mental image of global warming, and this is true worldwide, by the way. What you think of in global warming, you tend to have these images of Sahara desert, dropping deserts and heat waves. But what global warming really is less cold. That's what you got to think of. Wake up tomorrow morning, it's warmer than it was 30 years ago. That's what it is. Right now, it's probably about the same as it was 30 years ago. But the global warming is less cold. And there's a reason for that. And that's why I have, oh, shoot, I think I got this out of order. You see this glass? Oh, wait a minute, maybe I have it I put it, oh yeah, I got it out of order. I forgot to put it. This is a graph. I brushed off a talk that I gave about a year ago, and I gave that talk on July 1st. This is the maximum and minimum temperature on July 1st and the 30-year average. And I usually throw the slide out because I'm giving a talk on December 5th now. But I thought this is an interesting slide. It shows in the middle of summer that we're watching July 1st temperatures drop over the last 30 years, which is kind of interesting. Now, why is that? Well, and that's the reason I brought this right now. Really, the biggest greenhouse turns out is water vapor. Okay, and what's happening right now? I just looked up the dew point, which is a measure of how humid the air is, and that's why I brought this glass. The dew point in Albany right now is 22 degrees Fahrenheit. It's below freezing, which is why when I have a glass of ice water here, there's no condensation on it. Right now in Phoenix, Arizona, the dew point's close to 60 degrees. If this glass of water were in Arizona right now, it would be sweating like bullets. There's a lot more water in the air in warmer areas. Okay, so what's happening here is that here in Albany, you add carbon dioxide to the air, and there's no water in the air. Carbon dioxide really has a big effect as a blanket warming the atmosphere. Whereas if you add the water during the hot time of year, or if you add the carbon dioxide when there's a lot of water already there, it doesn't have that big of an effect here. So anyway, yeah, and this slide is out of order. I'll have to go. So basically, water vapor is the most important greenhouse gas, and therefore CO2 has a bigger effect when you add it to a cold atmosphere. So that's why the world is warming up most in the poles. The world is warming up mostly at night, and it's warming up mostly in winter, which is when you have very little water in there. So when you have the less amount of water, that's when you get the most warming. Okay, gardeners out there, this is a graph showing as you go through the year, you know, here in 1940, this is April, May, progresses through the year here. And this is the last day that you get below freezing. And then it stays above freezing all the way. And so in this case here, back in 1940, it was maybe about the last week of April. It was when you could plant your tomatoes or whatever outside. And then the first week of October, it goes below freezing. So this is a measure of the growing season length here, as measured by that minimum temperature going below freezing or not. And again, what you see here is, you know, when the spring starts, it starts anytime from the first week of April through the end of May, even early June back here. And the end of summer or the beginning of your frost has gone anywhere from the second week of September. We've had a couple of record years here recently. We've gone all the way into November, no freezing. And so if you look at what's happening here, spring is starting about a week. Each month is divided into 4 here. So you're seeing spring start about a week earlier than it did back in the 60s. And we're seeing the fall begin about a week and a half later in the year. So we're getting a longer growing season here gradually. And again, the interesting thing here, I think, is that there is, you know, humans are influencing climate only since about 1970 on, but it looks like maybe some of these trends were going on before that happened. So global warming here in Albany is giving us a longer growing season length here. Snow. We're all gonna shovel snow. I'm gonna break my back this year. I still use a snow shovel. I don't use fossil fuel power equipment, although I think I threw out my back one time last year. Here is seasonal snowfall in inches measured since the 1880s. And again, each dot, so 20 inches, we've had some years in the 20 inches of snow range, some years in the 100 inches of snow, and then the 30-year average. Since about 1970, we're watching snowfall drop from maybe 70 inches a year down to 60 inches a year. But we're going back to what was measured back in the early 1900s. So if you look at the overall trend in snowfall here in Albany, there's kind of in the period when humans are influencing things, snow is going down, which is you would expect, but we have had this much snow measured early on in the record here in Albany. Now this is the seasonal total. What about the one-day dumps? The biggest snowstorms ever. Oh, this is the figure that was out of order here. Sorry about that. This is the extreme snowfall. So this is the heaviest snow that you get in one day. And again, we have had 5 inches. Some year we only measure 5 inches. Some year we measure 20, 25 inches on the snowiest day. And this climatic trend here looks like it's going down a little bit. We probably had in the 1970s, we had maybe 11 inches was the typical number. It's down to 10 inches now, although it's fluctuating around there. There's not I don't see a really glaring trend there that just jumps out in terms of the heaviest snows that we've ever seen here in Albany. And by the way, I only have these measurements on my computer. I could probably dig them up somewhere. Daily snowfall measurements that do go back further than this. And so the next thing I'm going to show you is well, here I'm going to show you I'll show you the precipitation. Now, what about extreme precipitation? This is out of a government report where they were showing the observed change in very heavy precipitation across the United States, and they subdivided the US into different geographical regions here. And this is the 99th percentile precipitation. I'll explain what that means in a minute here. But what it shows is here in the Northeast, we've had a 71% increase in the heaviest precipitation since I think from 58 to 2012, out of about a 60-year period there. We were looking at a 70% change in that. Now I have the daily precipitation numbers, and here's what the daily extreme precipitation. What's the rainiest day of the whole year? Now, it turns out it rains about a third of the day here in Albany. And so, you know, a year has 365, so you're looking at about 100 days where you get rain. So the 99th percentile is very close to the rainiest day of the year for us here in Albany. And so what you're seeing here is the rainiest, the heaviest rain we ever get is 4 or 5 inches a day. And these are, I do remember these here. We had a couple of hurricanes come through here late in the season that dumped. And when that happens, Fuller Road floods up here. We get a lot of very fun stuff happening on those 4 inches. But the thing to notice here is this heavy rain has gone up. We were 2 inches a day was a typical, what I would expect. It's up to maybe 2.5 inches a day. But 2 to 2.5, that's not 77% like in that previous figure that I showed. So I go, how did they get that? Well, here's how they got that. They looked at the window from 58 to 2012, and they then drew a line through it, a linear regression it's called. And if you look at that, the beginning and end points of that is 1.7 inches here to 2.8, and then that is a 60% increase. But if you look at the actual measurements here, first of all, it's not it is kind of a monotonic trend, but I would say a more honest answer is that during the 19, over this period, I would say we've had about a 20% increase in this heaviest rainfall amount. And what is interesting is if you choose different periods here, you know, you can get grossly different numbers. You can almost get any number you want. If you look later in this figure, for example, there's a downward trend even. You know, if you look 98 to 2018, that it looks like the heaviest rains have actually dropped over the last 20 years maybe. But what I'm just saying is this is how you look at noisy data. You can look at it different ways. And by the way, we do have annual precipitation going back much further to the 1840s. And here's a graph showing, again, annual rain. We typically get 40 inches, 30 to 40 inches a year. So this is the 30-year average here. We have had wet years, which are in the 70, 60 inches a year. We have had dry years in the 20 inches. There's a factor of 2 fluctuation there in rainfall from year to year. And what you see here is a monotonic increase of rainfall since the 50s and 60s. But we're approaching the rainfall that we had back in the 1800s. Okay. And so there's, I don't have the daily measurements here, but my guess is back in the 1850s, if I could get a hold of daily temperature measurements, we probably had extreme rain events that were comparable. And by the way, the heaviest rainfall is a big part of this annual rainfall amount here. You know, that 5 inches is 10% of this number here. So there's a correlation between annual rainfall and the extreme rainfall. And my immediate guess is that we are approaching the heaviest rains we've ever seen, which were measured back in the 1850s here in Albany. Now, if you go back before rain gauges and thermometers, you have to start using proxy records. And I dug up, there's this beautiful database. In fact, you might know about, there's a tree ring database. So you can go get tree rings. And a couple of years ago, I went and got several trees. I tried to get trees as close to Albany as I could. And here's a couple of examples of where they go and measure tree ring width. And there's been various studies showing that how fast trees grows is correlated with temperature, but it's also correlated with a bunch of other factors like how much rain you get and whether there's farms in the area. There's many, many factors, but I view tree rings themselves as a climatic indicator. You know, so if you did look at tree ring width here, and this is, I found one Schenectady tree, and that had a long record, and I found a Middleburg tree, and here I'm plotting the actual scattered data. And again, I don't like scatter. Let's do the 30-year average of this. So what does this look like if you 30-year average those tree ring widths? This is the trends you get, and this is going back 600 years now of what tree rings, what has happened to the speed at which these two trees locally grow at. And what you see is kind of random fluctuations. Some years trees are growing faster than other years. And it looks like they're changing all the time, even way before humans started adding fossil fuels here. But it looks like there's been some interesting fluctuations in the rate at which trees grow in our area. Another record that I dug up about 10 years ago, someone went and measured called varve sediments that are at the bottom of Lake Erie. Did you know at one time the Great Lakes were landlocked? They were not connected to the ocean. They probably dried out at some point about 8,000 or 9,000 years ago. But anyway, what they measured in that was this is a good paper that appeared where they measured pollen and oxygen isotope ratios and a bunch of other stuff, and they could infer information about the temperature and rainfall that fed into the Great Lakes. So I thought this is a good indicator. And one of the figures in this paper showed it's a scale that's proportional to the temperature. It's an isotope ratio in the sediments there. And then they were able to get the moisture from pollen counts in the tree species distributions were there. And what they basically found, and this is a record that goes back 14,000 years, okay, of mud at the bottom of that lake. And what they found was it mapped as the Albany came out of the Ice Age, basically. And what it showed is that as Albany came out of the Ice Age, it warmed up a lot. And then it cooled down from about 2,000, 4,000 BC to today. And then there's an uptick recently, which might be current global warming that we're looking at here. But what you see here is I've shown in blue what is inferred as a very dry period. And in red is an area that was inferred to be very moist. And what you see is Albany went through, first of all, back here, it was under thousands of feet of ice. But as the ice receded, about 8 or 9, that's a typo there, it turned into a dry desert. It was probably like Mongolia or the Golden Desert at one point. But then it made a transition to, as it got warmer and warmer, it turned into a period that was quite a bit more moist than today. And so it then started to maybe look like a little further south of here, more moist conditions. And then it cooled off a little bit up until recent years. But over a bulk of the last several thousand years, probably Albany was warmer than today, according to Lake Erie sediment records there. Okay, so here's the ice ages. Ice sheets covered most of Canada and huge parts of Northern Europe. Here in Albany, I found this very good record from the New York State Museum has a good geology database of how the ice sheet was treated here. And this is a graph showing where the edge of the ice sheet was 20,000 years ago. It was out at Long Island. In fact, Long Island is a big glacial moraine. All the rocks got dumped there. And then it migrated up. It came through Albany here about 14,000 years ago. And it took it about 1,000 years to move from, I don't know, maybe Red Hook to Queensbury here, 15 to 14,000 years ago. And then it migrated up into Canada by about 12,000 years ago. So we were having Antarctica-like conditions here 12,000, 13,000, 14,000 years ago. And that changed an awful lot of stuff. I found as the ice sheet melted, it actually dammed up. This glacial Lake Iroquois was dammed up. And then when the ice finally broke through here in upper Lake Champlain, there was a huge flood of, probably for 1,000 years, a massive amount of water dumped into the Atlantic Ocean down the Hudson Valley, which was at that time a huge, it would have been a Lake Champlain kind of a valley, just flowing very rapidly. Sea levels. We've all heard about sea level rise. This is a graph showing the height of the sea level in meters there, going from about 20,000 years ago to today. So this is a transition from the last ice age to the current period. At about 10,000 years ago, the ice sheets pretty much disappeared. And sea levels have risen worldwide have risen about 100 meters, okay, over that time period. And there is a slight rise rate here. I did find people stick a ruler in the sand and measure the height on that ruler every 10 minutes. Heck, I think the tide gauge that are out there, they're looking at even 5-minute frequency. Every wave that goes by is a change in the sea level. Okay, but here is monthly average sea levels measured at Battery Park. And what you see here is since the 1850s, just a monotonic rise. There's been about a 40-centimeter rise in sea levels here in New York State. And what's interesting is global warming by humans, it really kicked in like in the 60s and 70s. And it's not obvious from this that the rise has changed dramatically at Battery Park when humans started probably contributing to some of that melting water in the oceans there. And so what I find interesting here is I dug up, I'm a map nut too. I love maps. I used to collect every map I could find. And I found this 1842 map of New York City. And I'm not sure how accurate it really is, but there are individual street intersections which still exist today. And then I went to Google Earth and I zoomed it into about the same setting there. And I wanted to compare what's happened. Surely with a 40-centimeter rise in sea level, you would expect a few blocks of the shoreline to have submerged below the ocean, right? But look what actually has happened over that time. This yellow area is all area that's above water today. That was submerged underwater 140 years. When they built the World Trade Center, they actually dumped all the fill out here. They built Battery Park. There's high rises today on stuff that was underwater, a football field out into the Hudson River. So humans over the last, from 1840s to today, this is a river delta, by the way. This is a vulnerable place where, and what it amounts to is you have real estate on the river. It's valuable, worth protecting, and people have been able to cope with this rising sea level that's happening there. But one final point I'll make here is this is from Al Gore's movie on CO2 and the ice ages. This is a graph showing the temperature over the last 500,000 years. Okay, and what you're seeing here is the hot periods and then cold, brief hot periods, long cold periods. For the last every 100,000 years, the Earth sinks into an ice age, and ice sheets cover the whole large fractions of the northern hemisphere. And the thing that's important to notice about this is that the last interglacial period, and this is about 120,000 years ago, was actually quite a bit warmer than today. And in fact, the sea levels were quite a bit higher back then, 120,000 years ago than today. And this is an example of the eastern coast of the US, New Jersey, New York. And if you actually look at what sea levels look like, during the last glacier maximum, 25,000 years ago, the Jersey shore was, I don't know, how far is that, 50, 60 miles offshore? The sea levels were that much lower so that you actually had a lot of land here exposed. And then what happened during the last interglacial period is there's evidence of seashores 30 or 40 miles inland in New Jersey. We find sand dunes and shoreline stuff there in what's called the Pine Barrens of New Jersey. Actually is what used to be a shoreline sand dune environment. So sea levels have changed from over hundreds of miles over the last 10,000, or the last 100,000 years, I should say. Let's see. Climate going back 5 million years. Again, this is a compressed picture. I showed you just this last 500,000 years here, ice ages every 100,000 years. If you go back even further in time than that, the 100,000 year ice age cycles changed to a 40,000 year ice age cycle, and that went back about 2.5 million years. And then before that point in time, apparently there was no permanent ice on Earth. Greenland and Antarctica didn't have ice, and so you actually entered into a period where you didn't have any more. This whole period is called the Pleistocene Ice Age because we actually had permanent ice that stood there all year. And before that, you actually had no ice on the Earth, and that's called the Pliocene. What's going to happen in the future? Okay, so the way we predict climate is we use physics-based models, which is what I worked with my whole career. I built subroutines in these physics models and implemented things. Now, climate models are really weather forecast models that are just run for a really long time. And you have to add a little bit more radiation and ocean physics to them to make them, because weather forecast models right now, I think, like keep sea surface temperatures constant, just because they change pretty slowly and it doesn't really affect your weather forecast for another week. But it does, of course, affect your climate. So you have to start predicting ocean temperatures. Weather models are regularly tested and evaluated, and we have had massive improvements. Today's 7-day forecasts or 10-day forecasts are remarkably accurate compared to 20 or 30 years ago. Climate models are a little bit more difficult to evaluate because we just don't have enough really robust measurements to say how good those climate models are. And the way you run weather models today is, I just give an example here. We actually run multiple forecast models. And here's an example of a snowstorm last year where a snowstorm went across Pennsylvania. And this is at one point where the different models, each curve here is the amount of snow that fell over about a 2-day period here. And you can see some models calculated very little snow, some models calculated a lot of snow. And it turns out, okay, that's why they tell you, you're probably gonna get 4 to 12 inches of snow. And, they don't know that number exactly. So they run all the models and just give you the window of that. And in fact, usually the observations are in the range of what some of the models are forecasting there. So that's the way weather forecasting works nowadays. And this is the way climate models are run also, because they also have a range of uncertainty about them. And so you have to run multiple climate models to actually decide what you think might happen. Now here I'm going to show simulations of the Earth's climate. And if you run these computer models, and this is the temperature of the whole world, by the way, since the 1880s, and if you run those climate models without humans doing anything, adding fossil fuels to the atmosphere, the temperature fluctuates a little bit here, but it stays remarkably constant. If you add greenhouse gases, carbon dioxide from burning fossil fuels, you find things start to take off in around 1960, 1970. We get this divergence between the natural climate and this human influenced climate here. And in fact, the observations match very nicely with the climate model projections. And so I think the scientific community is reasonably confident that we can explain the warming since 1970 is caused mostly by humans. That's the basis for that statement. But now let's take these models and run them out into the future. So here I'm going to take that figure there. This is the global warming over the last 200 years and put that on top of a graph where we're going to go out to 2100. Okay, so here's this warming that matches up pretty well. But here's what all the models calculate. They're kind of all over the map. They give, some of them get just another degree or so of warming. Some of them get 4 or 5 degrees of warming. So there's quite a range there. And if you actually talk to any of these individual research groups, they have enough flexibility. Japanese model will tell you, hey, we had, 1.5 degrees warming, but everybody, there's a factor of 2 floats around in the literature. This 1.5 degree might be 0.75. It might be 3. And the same thing with this Japanese model. They can tweak and tune a few parameters in the model to get double that warming, 10 degree Fahrenheit warming, and they can tweak and tune factors that'll bring it down to half. So when you add in all of this uncertainty here, there's a pretty wide range in what's going to happen globally to the world's climate over the next 100 years. So in the community, there's hot models that have 6 to 10 degrees centigrade warming. There's cold models that have 1 to 2 degrees centigrade warming. And when the media is confronted with this, what's going to happen? Usually the headlines are driven by these hot, or could get 10 degrees Fahrenheit, 10 degrees centigrade warmer, which is 20 degrees Fahrenheit warmer. That's a lot of warming. That generates headlines. Okay, but usually what isn't divulged is the uncertainty of those numbers. And so I'm kind of giving you an idea of what that uncertainty might be here. I found this New York State climate report. And one of the key figures here was, we're going to watch New York today. The average from 61 to 90 is going to either look like Virginia or like South Carolina by the late 2100s. Okay, and I went and I dug up the temperatures from, here's Albany right now. Our annual average is about 48 degrees. If the whole world does nothing, according to this New York State report, we're going to be 20 degrees warmer almost. It's 66 degrees. And if the whole world, by the way, if the other scenario that they show there is they have a lower emission, and if you look at how much lower, well, that means, if the whole world basically shuts down current, you can't drive anymore, you can't heat your homes anymore, you got to make sure the Chinese and Indians don't build any more power plants. This is a hugely invasive strategy that you have to, if you wanted to really cut fossil fuels by 30 or 40%, by the emission growth, What they're claiming is we're maybe only going to get 10 degrees Fahrenheit warming. So in either case, we're going to be off the charts here, according to that report. And so what I've done here is show you this is the same annual average temperatures for Albany that I showed you earlier in my talk. And I've just put these two warmings that are projected for the next 100 years here. And what I think you see here, and I want you to just put this in the context of the uncertainty that I showed you on the last figure. Okay, it looks to me like, if we're already supposed to be 18 degrees Fahrenheit warmer, like South Carolina, you can clearly see this 30-year average is already off the chart here. We're well into that period already. And so while the temperature is rising here, it's not rising as fast as that worst case projection tells us. But even the Roanoke, Virginia trend, which is the world cutting all its emissions by a lot, that seems to be a little bit hot too. So I think this New York State report has picked the hotter models to tell you what they think is going to happen. So it's kind of it's a cautionary note that climate could get this hot, but so far it looks like the world isn't warming up as fast as some of these projections are. Yeah, we'll leave it at that. So anyway, what I think, future trends in Albany, what's going to happen? I think the more scientifically objective answer is, well, you could either get a lot of warming, we could get maybe even some cooling. That last figure that I glossed over was someone in Europe asked the question, and what they found was for these European models, when you start focusing in on individual regions, just like I showed that graph, in the US, there's areas that are getting cooler. When you focus in on individual areas, New York could get cooler, just like Cornell is cooler relative to Albany. It's possible that we maybe get some cooling even here in Albany, upstate New York. We could get a lot of warming. I think that probably the scientifically most honest answer, what's going to happen here in upstate New York, is probably some warming, but the uncertainty range about that is really, really high, just because there's so much uncertainty in our ability to project what climate's going to be. So I'll summarize it. This is the end. New York climate has warmed and cooled since the 1850s. If you saw some of those, the temperature trends that I showed you measured here. Albany warming since the 70s is double the rate of the world in general. But I think you kind of saw that warming is really pretty small relative to the natural variability we see from year to year. Okay, extreme temperatures of both hot and cold are getting less frequent in Albany. So as the climate's warming, it's actually the extreme events are going away actually. New York tree rings show continuous climate change. Tree rings grow more and less each year due to I don't know what, but there's they also show evidence of climate changing continuous. Climate never does stay the same basically. Lake Erie sediments show a transition from the Ice Age. Over most of the past 8,000 years, Albany here was probably warmer than today, according to the sediments of deposited at the bottom of Lake Erie. Future climate trends, again, I'll just repeat what I said. We're probably going to see some warming, but there's a lot of uncertainty. And things are probably significantly different than the world average. Okay, that's it. Thanks. Again, notice no condensation. No water. No, if we had it in the summer, that would be dripping. Yeah.
Just breathe on it. Thanks, Chris. That was very interesting.
Thank you. I hope it wasn't too many numbers, but
Well, I can remember back to the 40s, and I started, as you were going through this, I was thinking, geez, I wish the heck I kept track of things, because it seems to be much more different than what I experienced as a child. Of course,
we have the numbers there.
I'm over now. I'm like extremes of either case. So, any comments? We use the mics and get on them. Yeah.
I have two questions that probably have simple answers. I hope so. What is it about the dip in temperatures toward 1970? I saw it in many of your graphs. What was going on?
No, that's That's a hugely debated. Why did the world get? I think you're referring to the temperatures getting cooler from like the 40s
Yeah.
to the 70s. Okay, the Dust Bowl era in the 30s were the hottest decades on record over most of the contiguous United States. A lot of the world records, if you look at record temperatures in Oklahoma and stuff, they were set back in the 30s. And the Dust Bowl era was a real drought. And that probably was a completely natural phenomenon. I remember that was one of the first questions I asked when I went to a scientific meeting as a graduate student in the 70s. I just assumed everybody understood why droughts happen. Why did the Dust Bowl happen in the US? And the answer I got was, we don't know. None of these climate models, I should just mention to you, none of the climate models get drought patterns accurately reproduced. So those models that so accurately reproduce the global average temperature, they don't predict like a 20-year drought in the middle of the US in the 30s. You know, that we don't know. It's the honest answer.
Okay. The other question is, what is a negative tree rate growth? I noticed it on the graph.
No, there's no, what that is a tree ring width. I don't think there was a negative there. Let's see. There was an, this was the thickness of the rings. So 0 here going up to 1 millimeter thick. So that's not a growth. Well, how thick the ring is how much the tree grew that year. So it's some of these years are almost nothing. You know.
Let's grab. Thank you.
Okay.
No, questions.
Has anybody done the research that you've done for Albany, the Buffalo, New York?
You know what's funny? I gave about 15 years ago. I have all this data, and I gave a talk in Buffalo, and I also gave a talk across the river in Waterloo, Canada. And I always grab the local, the closest station I can find in the U.S. Historical Climatology Network. It's a half hour of work. You dig it out and you plot it up this way. But I've looked at Buffalo temperatures. I'd have to go back and relook at my talk from 10 years ago that I gave. But yeah, no, there are, by the way, there are websites you can go to. There's Climate Explorer. The Berkeley Earth Science team you can click on a map and look at the local temperature records. But I should just caution you, when you do go to, the numbers I showed you for Albany were actually, they're what is in the Farmer's Almanac. They're what was written by hand. And if you do go to many websites today, everybody recognizes that there's huge problems. Here in Albany, for example, the Albany measurements, they only have been taken out at the airport since the airport was built. And before that, they were in downtown Albany, which is about 2 degrees Fahrenheit. You know, if you want to feel 2 degrees Fahrenheit of warming, which is global, you know, that's the global warming that's off the chart. Downtown Albany versus Albany Airport is 2 degrees. So there, if you want to feel how horrible climate is, that's 2 degrees warmer, try downtown Albany. Move away from Colony. You'll feel the difference there. But yeah, I have the numbers, and I'll dig up my talk from Buffalo.
In line with the previous question, looking at 1970, why did that so special? To me, that suggests, you know, sulfur dioxide and the Clean Air Act.
That is the way, by the way, the way these climate models are run, the way I understand in my discussions with other modelers, the way, see, if you look at all the things that humans are doing to climate, we're adding fossil fuels, which is a blanket, a warming effect, but we're also making the atmosphere more hazy. I grew up in LA. In fact, I was in LA when it was the worst. I literally could not breathe in the afternoon due to ozone destroying my mucous membranes. Your eyes were stinging. It was awful in the 60s, and it got way better since then. But particulate matter, the haze and smog that you see is a white, it's a cloud, and it reflects sunlight and it cools the earth. And what I can say is that the way the climate models get that cooling, the worldwide cooling, is by adding haze to the atmosphere and the sulfates. And you're absolutely right. What you're having happening there is the world is industrialized, and we're burning coal like the Dickens, not only in the US, but in Europe, and it starts. Now, here's my only worry about that. That's a little control knob right now. You can make the climate get colder by adding a little more haze, and make it warmer, adding a little less haze. And this is one of the ways that they do get that warming. But the only thing I see is right now, the world is adding coal worldwide at a rate that just makes what happened in the US in the 30s look like nothing. China and India are building a new coal plant every week, and the amount of, they're all uncontrolled emissions. There's just a huge amount of dust being, if you go to China and Asia, the air quality and the haze there is, I would venture that my guess is that it's way worse than anything we did in the US, but it is likely that the haze caused by power plants was a big factor contributing to the warming. And I know locally here in the US and in Europe, that haze has been brought down. But I think in the rest of the world, I don't know. I don't think the haze is gone down world.
Yeah, it sounds kind of an ugly trade-off between human health and global health.
That's right. No, you're right. It's there's a definite trade. Yeah.
So going back to the question about Albany at the airport.
Yeah. The movement.
Technology, has the accuracy of the readings and all had an impact on any of the accuracy?
That's a really good question. And what's funny is I've heard reports of yes, the technology in the old days you used to measure. I have given whole talks on how we measure temperature. And the conclusion of the talks are you really can't measure temperature to the accuracy that you're seeing here. It's amazing if you look at the requirements for setting up a weather station. If you want to report it into this database that keeps track of, you have to be 50 feet away from an asphalt lot. It's got to be this high off the ground. If an asphalt parking lot is 20 degrees warmer than a foot above the ground. There's huge fluctuations locally, and you can't have bushes nearby. But anyway, one of the things they did in these standard weather gauges out at the airport is in the 1990s, they switched from, they used to have a human observer walk out, and I think they actually recorded the temperature hourly. That was the job of a weather observer at the Albany airport, to measure it every hour and then keep track of the max and min. And the weather service cut that out. They couldn't afford it anymore, and they switched over to these what are called automatic system, and ASOS. They call it ASOS. It stands for automatic weather. I forget what it stands for, but it's an automated thing that radios into. And what they noticed happened there was right away after it was set up, there was a bunch of super cold temperatures measured, colder than ever measured. And it turned out they weren't shoveling the path out. So what happened was the snow built up, and so you ended up measuring something closer to the ground. And if you get close to the ground on a cold, snowy night where it's clear sky, temperatures are 20, 30 degrees colder than they would be if you got rid of the snow. And so we've got to go. They're not shoveling the snow, but what they're doing is correcting. Oh, when we see a clear night when it's cold, add 10 degrees to that number. That's what they're doing to current temperature measurements. But they've been huge, and there's urban heat island effects. The airport used to be all grassy forest, and now it's a lot of concrete and asphalt that holds a lot of heat. And so there is an urban heat island bias that's contributing to the warming that we're seeing here in Albany. In fact, a good fraction of the warming in Albany could be this urban heat island effect, even during the period before the airport. But there's a lot I don't want to plant seeds in your head here, but there's a lot of uncertainty in our ability to measure. And there's a lot of variability. I showed you that first figure showing right now, over there it's 5 degrees warmer than over there in Gilbert. Okay, there's that type of variability. One back there.
This is more of an observation than a question.
Okay.
I'm something of a numbers guy myself, so I really appreciated all your graphs.
Oh,
and-
thanks.
And the,
Good to high five.
and the 30-day average thing.
30-year average.
That's what I meant, 30-year average. Those are a lot more reliable. However, I also appreciated your bit of skepticism regarding that linear regression. That was wrong, because any regression model depends so much on the starting point, the end point, the amount of variability in between, the measuring period that you use. And so you appropriately express some skepticism as to how useful that regression.
I swear to God, this is a very political topic, and I'm accustomed to the average community talk I give this to. And I'm convinced that we are in an era where that particular report, I'm pretty sure, if you showed in my numbers, 20% increase, it wouldn't have been published. We're in an environment where if you want to get published, you have to show something alarming, or it helps to have that. The squeaky wheel gets the oil, or the attention is being. And like I say, even the New York report that I showed, I think they looked at the hotter models to tell us what's going to happen here in New York. And it's a similar, I view the state of climate science today, it's very influenced by politics and media ads or something. It's a very controversial area. And I try to keep it clear of that a little bit, but the first time I gave this talk, someone, I think it was, I got a call from, it was after Al Gore's movie came out, and they said, we want to hear a debate, a pro and a con. And at that time, I didn't have a strong, I don't consider myself, although I do some climate related research, I don't consider myself a climate scientist at all, but I do work with the same data and techniques that they use, but we're looking for a skeptic. Can you be a skeptic? I said, well, look, I'll tell you what, I'll read what the skeptical scientists say. Richard Lindzen at MIT, Judith Curry at Georgia Tech. There are scientists who harbor very public skepticism of a lot of these claims. So I said, I'll read what they say and tell you their arguments. And so that ended up being one of my first introductions to the whole field. And I found it very interesting. I love science is not settled. It never is settled. And the debates are where the forefront of knowledge is even. There's so much to be learned. And implying that we know everything already is kind of unscientific.
Thank you.
Oh, thank you. Thanks for your comment. That was good to hear.
Anyone else? Do you think the increase of temperature since the 1970s in Albany relative to globally, is that like twice
as much? Yeah.
Is it simply because it's reflecting like a global warming across the whole Northeast? Or is it something special about Albany, the surrounding area that?
Well, you saw that figure there. If you look at what is kind of interesting, let me get out of this and go back to that. There is the
Politicians, yeah, that's
Yeah, they pull a lot of hot air in.
yeah, exactly.
yeah, this figure here, I think this is okay, so again, now this is the 100-year change, right? But most of this is since 1970. If you do look at the trends almost everywhere, what you see is a warming from 40s, cooling, and a big warming since, and then that's true across. So what you see, yes, there are hot spots here. California, the northern Great Plains, Northeast Florida, the tip of Florida, and then there's cooling here in Alabama. And I have heard people, this cooling in Alabama, there's several papers that have been published, and they think it has something to do with the way they're irrigating the cotton fields there. There's forests coming back. There's forests that are regrowing here that were chopped down in the 1800s that are, and the forests are a cooler place than a field, or a cotton field or something like this. Anyway, I have heard various explanations, but that's a hot area. Even in California, they massive land use changes there. When you start irrigating areas and strip away forests and even some of these have city, there are urban effects also that kick in. But this is I could mention probably 50 factors that might explain why any of these changes are happening. But that's the pattern that you see there. Yeah, is it global? I don't know.
You can see New England seems to be hot, and so is Eastern.
Yeah, the whole Boswash corridor
Right.
is, and I'm pretty sure, I would expect some of that is even an urban heat island kind of a thing there. But although what is amazing is, one thing that's really dramatically changed here in the Northeast is that this whole place was denuded of forests back in the 1850s. And the forests are just rebounding amazingly. And I know that's huge. That changes the reflection of sunlight. That changes the water vapor budget in the air. Water vapor is a big greenhouse gas. There's many ecosystem factors that have changed over that period that are all going to influence that these trends that you see. Another question?
Well, I'm still thinking about 1970. And I remember.
The good old days, the best rock and roll. Yeah.
Seeing it in University of Michigan at an event for the very first Earth Day.
Earth Day,
In
yeah.
1970, when I was in graduate school there. But do you think it has something to do with air conditioning or with the increase in production of cars and the use of cars? I'm just trying to.
Well, the
think about-
current, I think the current answer to why we're getting warming since the 70s is it, by the way, it's a global phenomenon and worldwide fossil fuel use. Heck, I don't have it in this talk, but worldwide fossil use has just exponentially grown since the 70s. So we are seeing the entire world burn by the way, one piece of advice I have talked to environmental groups and in terms of your carbon footprint, the biggest predictor of your carbon footprint is the amount of dollars you spend. There's a one-to-one correlation between dollars spent and fossil fuels used, because basically whatever you do that you call a high standard of living, it involves a lot of energy. And right now, the cheapest way to get energy is fossil fuels. And so that's why when you shop for something, you find the cheapest way to make that product, which is going to be with fossil fuels. And anyway, so if you want a carbon app for your phone, just look at the dollars. If you spend $2 for a cup of coffee at McDonald's versus $4 at Starbucks, you're having double the global warming impact if you follow the carbon cost of dollars. So no, there's no question, according to the current consensus of the scientific view there, that since the 70s, fossil fuel use has skyrocketed, CO2 levels have skyrocketed, standards of living have skyrocketed also. But so if you want to be like your grandma from the 30s, if you spend less money, you have less carbon. That's a cute little. Remember that. That's the most. It's gonna. I guarantee you, if everybody would just cut the amount of money they spend by half. And by the way, that's if you do want to cut your carbon footprint, you're gonna see that your spending goes way down by that amount, and that's going to be way more effective than the Paris Climate Treaty or Kyoto or something. It's the governments aren't going to easily do too much to influence human behaviors, but you personally can change your carbon footprint by spending less money.
Anyone else will comment? Chris, thank you so much.
Oh, I didn't know.
We have our programs ready before the spring, so stay tuned in the next few weeks. We'll send it out to you. Ed, anything to add?
No, I think you're right. We just say January 30th is, hopefully Philip Morris will be back on his feet, literally.
Do you want to stop
to attend?
Stop the
Yeah.
recording.
Happy holidays, everyone.
Yeah.
Chris, I'm Martha Rosette. I taught in the English department.
Oh, really?
Years.
Okay.
This is Rachel Dressler, who taught at
Oh, okay.
And we're very involved with a program in